GATE 2016 Civil Engineering Set 2 Question 18. A water supply board is responsible for treating 1500 meter cube per day of water. A settling column analysis indicates that an overflow rate of 20 meters per day will produce satisfactory removal for a depth of 3.1 meters. It is decided to have two circular settling tanks in parallel. The required diameter expressed in meter of the settling tanks is. The relevant NPTEL reference has been cited. In order to calculate the surface overflow rate of a sedimentation tank, assuming a sedimentation tank of length L, width B and height H, we will find the surface overflow rate by comparing the retention times. So, the retention time of the tank will be equal to the volume of the tank divided by the volumetric flow rate. This is equivalent to treating V volume of water at a rate of Q. So the time needed would be V by Q. So volume for a cuboidal tank can be taken as LBH divided by Q. This is our first equation. Similarly, we can get the retention time using the concept of sedimentation. So assuming a particle enters the tank at the topmost point and it settles at the bottommost point on the other side for 100% efficiency. So for this, the retention time should be equal to the height of the tank divided by the velocity. So it will settle at a speed of V in a time tr for a height of h. This is our second equation. So comparing 1 and 2, we will get LBH by Q equals h by V. Using this, we will get V equals Q over LB. That is our surface overflow rate. So if a particle has a speed of settling greater than the surface overflow rate, that is V0, it settles with 100% efficiency. But if it has a speed of settling less than V0, it settles with a efficiency of ratio Vs by V0. In this question, we have been given the total flow rate as 1500 meter cube per day for the water supply board. It is said that the number of tanks needed here are 2. So both these tanks are connected in parallel and hence will treat a equal volume of water. So Q in individual tank will be equal to the total volume by 2. This will be equal to 1500 divided by 2, that would turn out to be 750 meter cube per day. So surface overflow rate is given by Q by LB, but the tanks in this case are circular. So LB is the area of the tank. So we will replace this by area of a circular tank, that would be pi d square by 4. So using this, the area would be Q by V0. Here Q is 750 and V0 is 20. Q is in the units of meter cube per day and V0 is in meters per day. So we will get the area of the tank as 37.5 meter square. The area is pi d square by 4 equals 37.5. So using this to get the diameter, that would be 4 into 37.5 divided by 22 by 7, this whole term to the power 0.5. The value would turn out to be 6.908 meters. This can be rounded off to 6.91 meter for each of the circular tanks to treat 750 meter cube per day of water at a surface overflow rate of 20 meters per day. So the required diameter of the settling tanks is 6.91 meters. The relevant NPTEL reference has been mentioned.